Okay, today's objective is to solve equations with variables on both sides. Okay, the thing we need to remember to do when we have variables on both sides is to move the variables first. Okay, so we have to remember to move our variables first. And we move them by using inverse operations just like we did on the other equations that we've been doing. So problem number 1, 5x minus 2 equals 3x plus 4. So to solve these variables on both sides problems, you pick either 5x or 3x and you move it to the other side. So I'm going to choose 3x. So that means this 3x has to move to the other side. So what's the opposite of positive 3x? Negative 3x. 3x minus 3x is going to cancel. Over here, 5x minus 3x. 5x minus 3x is 2x. Bring down the minus 2 and bring down the 4. Now that I moved that 3x, it looks just like the problems that we worked on before. So we add 2 to both sides. You get 2x equals 6. Divide by 2, and x equals 3. So the key thing is that you pick one of the sets of variables, you move it to the other side by using inverse operations. Okay, number 2. 7k equals 4k plus 15. So again, I have to pick either one side or the other to move those variables to. So I'm going to choose to move this 4k to the other side. So I do minus 4k, minus 4k. 7k minus 4k is 3k equals 15. Divide by 3, and k equals 5. Okay, number 3. Number 3 is 3 times x minus 1 equals 9 plus x. Now this one's a little bit different because it has those parentheses, so we distribute and distribute. 3 times x is 3x. 3 times 1 is 3, so 3x minus 3 on that side equals 9 plus x. Now again, variables on both sides, pick one to move, so I'm going to pick this plus x. To move it to the other side, I write minus x. 3x minus x is 2x. Bring down the minus 3 and equals 9, and then it's just like all the other problems that we've been doing. Add 3, 2x equals 12, divide by 2, x equals 6. So they are going to get more complicated. They are going to have distributive property and like terms in them. So let's look at number 4. So again, we've got parentheses, so that means distributive. There's no number in front of those parentheses, so we're going to put a 1. So bring the 5 down, distribute that negative 1, so minus 1n, and then plus 4. Negative and negative makes a positive. Distribute over here. 3 times n is 3n. 3 times 2 is 6. Now on this left side, I have to put like terms together again, so 5 plus 4 is 9. Minus n equals 3n plus 6. And again, we pick one of our variables to move. I'm going to pick the minus n, so add n, add n. So 9 equals 4n plus 6. Subtract 6 from both sides. And you get 3 equals 4n. Then we divide by 4. Now when I take 3 and divide by 4, if I put it in my calculator, I get 0.75. So I'll take that answer, or remember I'll take the fraction also, so 3/4. Number 5. 4y plus 7 minus y equals 10 plus 3y. So I'm going to do my like terms. 4y minus y is 3y plus 7 equals 10 plus 3y. Now when I move one of the variables, I'm going to subtract 3y, subtract 3y. 3y minus 3y, they cancel out on both sides, so I'm left with 7 equals 10. So 7 does not equal 10. That's not a true statement. So what our answer is no solution. Because 7 does not equal 10, our answer is no solution. What that means is there's no value for y to plug in here to have it be a true statement. So there is no answer. There's no number that'll work. So no solution. So let's make a note about that. And the variables cancel out. And the two numbers are not equal. The answer is no solution. Okay. Number 6. 2c plus 7 plus c equals negative 14 plus 3c plus 21. So like terms, 2c plus c is 3c plus the 7 equals 3c, negative 14 plus 21 is 7. So when I get rid of the c's, minus 3c, I get 7 equals 7. So that is a true statement because 7 does equal 7. That's a true statement. So our answer is all real numbers. What that answer means is any number that we put in there for c would come out to be a true statement. So it wouldn't matter if it was a positive number, a negative number, a fraction, a decimal. Any number that we picked and put in here for c on both sides, we would get an equal, we'd get it to be equal on both sides. Okay? So let's make a note about that. When the variables cancel, and the two numbers left are equal, then the answer is all real numbers.